Hi everyone, and welcome to Camfil's latest webinar, from hospitals to offices and schools, utilising HEPA air purifiers to reduce the risk of airborne contamination. Today's presentation, my name is David Cruz. I'm going to be the moderator today, and today's presentation is going to focus on, today's agenda is going to focus on 5 key topics. The first one is to remember that there's many benefits to clean air, and there's many challenges that we have to address. So to start off this talk, we'll talk about these benefits that a clean air will bring to your organization. The second part, we'll talk about what the World Health Organization say and the type of technology that's recommended. We all can see it through many different publications, the words HEPA air purifiers, so we'll focus on HEPA air purifiers. We're going to talk about ensuring compliance to standards and recommendations to make sure that when you're looking at a unit or when you're looking at air purifiers, that you understand what the standards are to meet the criteria for choosing the right system. And then, when should you utilize an air purifier? How should you utilize an air purifier, and how can you optimize the performance of the air purifier within your environment? As I said, today I'll be the moderator, and I'll bring together the 2 of our experts. Alan Sweeney will be first and Stefan Hurrier is second. I'll introduce Alan first.
Thanks, David, and thanks, Stefan. Hi, everybody. My name is Alan Sweeney. I'm the segment manager for Clean Process Europe for Camfil. I have over 30 years experience in air filtration. Camfil have over 55. And I'm one of the key contacts for our global pharmaceutical and life science customers, where we've been using HEPAs for many, many years. I'm a relatively experienced speaker at many events and exhibitions around Europe. I hope I've met some of you. I'm married with 4 children and a very crazy dog, as I was reminded recently, and my hobbies vary. So I'll pass over to Stefan now, who'll tell you a little bit about himself.
Thank you, Alan. Thank you, David, and hi, everyone. My name is Stefan Hurrier. I am sitting close to Paris. I am EMEA Facility Management Segment Manager. I've been working at Camfil for 10 years. I have 3 children, and when I'm not traveling over EMEA for business, I like sailing. So let's start with a cleaner benefit. We need to place air quality at the top of the environmental and human health agenda. The quality of the air we breathe has a huge impact on our health and well-being. Globally, air pollution is the leading environmental cause of shortened life, contributing to the equivalent of 5% all deaths worldwide. Let's now have a look at the byproduct that is created by HEPA air purifier. We are talking about clean air and its benefits. Well, obviously, I think everyone knows that clean air can protect against airborne viruses, but it can also help in other ways, from improved mood, cleaner lungs, better sleep, and even improved digestion. One of the most forgotten facts is that clean air can actually improve productivity also. In a study done in US, it was seen that a $40 investment per employee in indoor air quality can lead to an increase of $6,500 in employee productivity. So remember, clean air is not for pandemic, it's for life. So when we look at clean air, what are the key concerns that we are focused on? Well, in a recent air quality recommendation document released by the World Health Organization, they have really focused on 6 key contaminants that can be broken down into key categories, which are for particulate matter, the WHO focused on 2 levels, PM 2.5 and PM 10. When we look at molecular contamination concern, we focus on nitrogen dioxide, sulfur dioxide, hydrogen sulfide, and carbon dioxide. For the purpose of this webinar, we are going to focus on the 3rd contamination risk. We classified it as microbial contamination. In this category, we talk about airborne viruses and bacteria that are transmissible through the air. I think we all know the main one that will be the focus on today's webinar. But remember, there are many other airborne viruses and bacteria that are important to protect against. Did you know that in June 2020, 249 of the world's leading scientists sent a letter to the WHO to declare that the COVID was an airborne disease. Since then, many things happened. Government released guidelines, standards were developed, and regulations were released. It took until April 2021 for the WHO to finally put onto their website that yes, COVID is an airborne disease. But what does their website say about the spread of airborne viruses now? The first highlighted line is simple, that the virus transmits between people who are within 1 meter distance of each other, and transmission occurs when people breathe the virus in. What is really interested in is the second bullet point, that the virus spread in poorly ventilated area or crowded area, and it can travel further than 1 meter distance in these facilities. So now we know the virus travels in indoor environments. The next thing to look at is what makes a high-risk environment. For this, I took a snippet from the website of the CDC, or the Center for Disease Control. In this, they highlighted 3 key factors that can cause an increase in the risk. Number 1, enclosed space and poorly ventilated area. Number 2, area of increased exhalation. So anywhere you breathe heavier, speak louder, or need to shout. Number 3, area that can prolong our exposure. This is anywhere that we spend more than 15 minutes. So I am sure we can all agree that all our offices probably fit into all these categories. One question that usually pops up is, can you share with us a few examples of outbreak in indoor environments? To keep this on international theme, I will show 4 different outbreaks that are happening in different types of facility and offices around the world. The first is a use case that happened in Germany with toner meat processing plant. According to reports, more than 1,000 staff were infected in this facility. This case is of significant importance to Camfil, as we are part of the team that helped get Tony's back operational again after they reached out to us to support them. We have a great case study around this, and if anyone is interested in it, please let me know and I can share this with you. The second is a gym where an outbreak caused 500 COVID positive cases and was the cause of 36 workplace outbreaks in the week that followed. In Ireland, the government announced that half of the COVID workplace outbreak were caused in just 150 buildings. This highlighted the size of each outbreak and how it can affect businesses. In the UK, close to 300 workers tested positive in a sandwich making facility, which I'm sure you can all agree is a significant number. And finally, from a last week's study in Switzerland, that clearly shows that the risk of transmission is multiplied by 6 in a classroom without or with poor ventilation. So what guideline should we follow? At Camfil, we have many publications we can share, but to make this more universal, let's use the WHO guideline and the REVA COVID guideline. For the WHO, the main guideline to examine is the roadmap to improve and ensure good indoor environment document. At the early stage of the pandemic, it was agreed that ventilation and filtration were and remain key to fight against COVID-19. COVID-19 also put indoor air quality on the top of agenda regarding risk assessment. Here are some guideline examples that you can easily access on the REV. The REVA COVID-19 guidance, release 4.1, or the WHO roadmap to improve and ensure good indoor ventilation in the context of COVID-19. The strategy for healthy building consists on increasing ventilation rate, increasing filter efficiency, 100% supply air if possible, last but not least, supplementing with portable air cleaners. So how reduce the risk of spread? A person can release viruses into the air through talking, coughing, sneezing, or even just breathing. But did you know that in poorly ventilated area, viruses can last for between 5 and 16 hours in the air? The virus needs particulate to travel through the air. Without a vehicle in the air, the virus will fall on the floor and surface. By other means, this is where general cleaning activity are helping to reduce the risk. But in areas that use recirculation, this can mean that the virus may travel to other areas in your building. So what can Camfil offer to help you to reduce the risk of spread? Unfortunately, we cannot stop people from going into the office sick. But what we aim to do is to reduce the risk of virus outbreak within your buildings by utilizing the cleaner technologies such as filter and air purifier. We can remove the particulate from the air and reduce the risk of airborne transmission. The study from the CDC is clear. 0% particle reduction without opening the window and without portable air cleaners. 29% particle reduction with opening the window and without portable air cleaners. Last but not least, 81% particle reduction with opening the window and with portable air cleaner. Please remember, particulate removal is a key success factor to fight against viruses. Now we'll pass over to my colleague Alan, who will tell you more about solution. Alan, the floor is yours.
Thanks very much, Stefan, for that explanation. So what are the solutions? Many studies have been carried out globally, as Stefan said. In Ireland, for instance, my home country, large university, UCD, found that air purifiers have a fourfold increase in the removal of aerosol contaminants. In the USA, for instance, the CDC, or Center for Disease Control that Stefan referenced, have shown that 2 HEPAs in a system can lead to over 70% reduction in COVID presence. And Cambridge University have also run projects in hospital where they used HEPAs in the inlet systems, and after 5 days, no COVID presence was found in the wards. So real-world data is showing us that filters clean COVID-causing viruses from the air. But what are HEPA filters? Air cleaners may be useful in clinical spaces, but what are HEPAs? There are many types of HEPAs, and they've been around for many, many years. If you have an existing HVAC or clean room system, you'll be used to seeing panel type HEPAs or deep HEPAs in air handling units or other systems. If you have HEPAs or you have an air handling unit or ventilated system, you currently have a mechanically ventilated space, talk to the professionals or ask Camfil locally, can you add HEPAs to your system? But it needs to be handled correctly because you don't have adverse results on the air change rates or the pressure drops in your systems. The current recommendations are, if you do not have the ability to change what's there, to use plug-and-play systems. And these plug-and-play systems should be equipped with real HEPA technology and should be an easy enough solution to implement. So again, why HEPA filtration? HEPAs are being recommended. What are they? Where are they typically used? They've been around for many years and they transcend many, many market sectors. We've been using them in hospitals, in pharmaceutical industry, in the nuclear facilities to protect people from dangerous contaminants there. Very importantly, they've been used, as you can see here, in biosafety laboratories. And that's where we're handling these very, very dangerous viruses and other dangerous pollutants. And they're used in R&D facilities and universities. So they're widely used in industries, and they started many, many years ago. They're proven tech. They're not new tech. They're around for over 60 years since the inception of our engagement with the nuclear science industry. HEPAs have been a protective method. Since these early years, you've seen various technical updates to HEPA filters. And one other thing that's also evolved is the testing standards. HEPA filters have always had a part to play in controlling airborne contaminants for various high-tech industries and hospitals, etc. And because of this, there have been many upgrades of the standards to ensure that the HEPA filter you choose for whatever purpose you're going to use it for is fit for purpose. And that includes in air cleaners. So the current applicable standard, as we can see here in the top right, is the EN 1822 or ISO 29463 standard. And this is a test that must be carried out in a manufacturer's facility on every product called a HEPA filter. It is a must test, not an optional or batch test. It's important to remember that it's not a suggestion to test it. It's a rule, and a HEPA must be tested to ensure it's fit for purpose and receive an individual test certificate. So are only HEPAs out there, you might think? Why a HEPA filter? Well, any filter work to reduce viruses. If we look at the viruses on the right-hand side there, from tuberculosis down to smallpox, tuberculosis tends to be between 0.85 to 0.9 microns. Our COVID enemy at the moment is down in the 0.15 to 0.25 area, so on the further left of the graph. And you can see the differences with varying types of filters against those particle sizes and by default the viruses, which typically travel on particles in the air. So the answer is yes. Other filters other than HEPAs can help you, but to differing degrees. For instance, if you look at an EPM 2.5 filter, it can capture about 20% of the airborne contaminants, as you'll see on the graph. But is 20% enough? I'm sure everybody here listening is saying no. So let's move up to an EPM 190% filter. Here we increase the capture rate to between 75 and 80%. But again, with a dangerous virus or a microbial contaminant, is this enough? Realistically, we want to ensure that as much contaminant is captured as possible. So let's look at the red line, the EN 1822 tested H13 HEPA filter. This will capture 99.95% of the airborne contaminants that pass through the filter, and that's why fine HEPA filters, real HEPA filters, not ASHRAE or MERV rated filters are recommended, as the HEPAs dramatically reduce the risk of contamination. So the question is simply, brilliant. If I simply just buy a HEPA filter that says HEPA on it, my environment will be safe. Unfortunately, this is not the case. We often see people saying HEPA-like, true HEPA, HEPA performance. And this is where compliance to standards, labeling, individual testing, serial numbering apply. Remember, the World Health Organization recommends HEPA filters that are tested to EN 1822. They give the guideline to use. So let's have a look at EN 1822 and let's see what that guideline says, and I'll give you some tips as to how to ensure your filter complies with that guideline. EN 1822 is a very rigorous testing method. It's got 5 separate parts. Part 1 means you've got to classify. It gives us the list of classifications and the required tests we've got to do. It tells us what type of aerosol, which is a test dust basically, for the HEPAs. It tells us the type of aerosol we must choose in our facilities to test. It tells us that we must test our media to ensure we get the most penetrating particle size. And then it gives us good guidelines on actually testing the filter. In all instances, what we've got to do is introduce an aerosol. So what we do is you take a filter, we put it individually in the test rig, introduce an aerosol, and then with laser particle counters, we test that filter against a range of particle sizes, large and small, typically around the MPPS, or most penetrating particle size, the most difficult particle size to catch. So it's tested against the most difficult contaminant it's got to catch, and then it gets its rated efficiency. Importantly, every HEPA filters, even HEPAs in air purifiers, should be individually tested and receive what we're going to see in the next slide, a test certificate. This should give you information about the performance of the filter during the EN 1822 test protocol. It should include its final filtration efficiency, the final pressure drop, the testing conditions that the filter was put under, and it should be produced by the filter manufacturer for each filter that they claim is a HEPA filter. Not a batch test protocol, nothing else. Individual serial numbered tested HEPA filters ensures we're all safe, and that's what the World Health Organization are recommending. So it's very easy. All HEPAs are equal. A HEPA is a HEPA. Correct, Stefan?
No, Alan, I wish it was so. But before you go on, one thing everyone needs to remember is, unfortunately, not all HEPA filters are created equal. In this video, we are going to show 2 HEPA filters. One is certified EN 8022 2019, and one that is claiming to be a HEPA filter, but not individually tested. As you can see in the video, the 2 HEPA filters are being tested against aerosol. On the top, we can see a certified HEPA, and on the bottom, we can see a non-certified HEPA filter. I think we can all agree now that not all HEPA filters are made equal. Yes, it could be using HEPA media, but does not make it a HEPA filters.
Thanks, Stefan. A picture tells 1,000 words. So we know it must be a real HEPA filter, an absolute HEPA filter, a tested, certified HEPA filter. Let's look at how we choose an air purifier with that HEPA technology included. So again, we're going to look at the good advice given in the World Health Organization's roadmap, which you've referenced a couple of times. For naturally ventilated spaces, the recommendation here is to assess the open locations in the space and try to introduce some cross-ventilation effects. Open a window, open a door. And there are some exceptions to this rule, but generally cross-ventilation or increasing the ventilation rate in the room by bringing in air into the room. If that doesn't increase the ventilation or air changes per hour rate to an acceptable quantity, the advice is to try to reduce the number of people in the room or the occupancy rate to suit the liters per second per person rate that are recommended in some other guidelines. But if no other short-term strategy, can be operated, consideration of a standalone HEPA filter air cleaner is advised. And then for mechanically ventilated spaces, here they recommend that you use a trusted HVAC professional and assess the current state of the system and see if there's any opportunity to increase and maintain the ventilation rate to the WHO and other bodies' advised settings, or if this is not possible, supplement that ventilation using natural ventilation again, or if this is not an option, again try decrease room occupancy, which we know is not so easy in schools and hospitals and in packed indoor buildings. And again, if no other strategy can be adopted or operated, the consideration of a standalone HEPA air filter is advised. Positioning of the air purifier is important. Please take a professional advice as to where to put it. And then there's a very important note on recirculated air. Recirculated air should be carefully evaluated in consultation with a HVAC professional or your local Camfil office if needed. Look at the possibility to include HEPA filters on return air ducts of the system, but always make sure your system can handle the associated increase in pressure because this could have an adverse effect. And again, if this is not an option, they recommend the consideration of a standalone HEPA air filter cleaner. So we've mentioned choosing the correct air solution, clean air solution, according to the correct standards. You've got to look at the technology standards and are the components certified. A good way to ensure this is to ensure that every HEPA air purifier you choose has a tested and certified to EN 1822 HEPA filter. So always ensure you're getting HEPAs certified with a traceable individual test cert. Then look at the air changes in the space and also ensure the technology that you do choose doesn't generate any other contaminants by design. Ask questions like if it sterilizes, are the chemicals it's using safe? If it has HEPA air filters, does all the air go through the filter in a sealed and controlled manner? Is the HEPA certified to EN 1822, as we've said? And finally, is the supplier accredited? Are they professional and active in the clean air industry for a number of years? After all, clean air is a human right. So the recommendations on air changes. Here we look at some well-known public standards that are out there. The Building for Health from Harvard. If you take these guidelines as an example, they've identified that the optimal air change rates for school environments is somewhere between 4 to 5, with above that being excellent or ideal, and below that being the bare minimum or very low. So in indoor environments, trying to get an air change of between 3 and 5 air changes is good. But in gyms, leisure facilities, or other areas where people might be exercising, exhaling more air, breathing more air, that might need to be stepped up, and 10 liters per second per person may be too low. So for anybody to achieve success and look at a successful outcome to protecting people indoors, you've got to work out the number of air changes you need using the volume of the room, the air changes per hour, and other items like that. Or if you need access to a tool to help you do that for you, Camfil have on our websites available a very simple sizing tool. Going to give you an example here. We've got an office environment. It's 9 by 10 meters in width and length, and it's an average height, so 2.8. So we end up with a 252 meters cubed space. The current HVAC system creates 1 air change. To become ideal, it needs 3 to 6 air changes. So you plug that information into this tool. It'll work out what's required and give you some recommendations. In this instance, it's going to ask you to use 4 air purifiers, easily located in the space, to build in 3 cc 400 units, as they're called, built into the ceiling perhaps, to bring in some fresh air from outside as well. to use one large industrial from our industrial range, CC6000, or a CC2000 that can be mobile in the room. But again, we have a tool available if needed. And positioning these air purifiers is important. So to position the air purifier when you're looking at recirculating systems, this will take the room from inside the room and clean it. You need to be very, very sure here that you've got certified HEPA filters as you're dealing with possibly the virus on the dust particles in the room. It's floor standing, and it's positioned in the room in the best position that's possible, just being sure you don't obscure any of the inlets or outlets and you get a good airflow in the building. But again, ask your local professional for advice on positioning in that instance. You can also put an air purifier mounted perhaps on the wall to bring in some fresh air ducted to outside. Here, you're going to put the room under positive pressure. You'll bring in some fresh air from outside, clean it through a HEPA filter, push it into the room to increase the quantity of air in the room, and by default put it under positive pressure, we call it. And this will mean that any contaminants in the room are being filtered and removed, but importantly, if you open the door, the air leaves the room and you don't allow any other contaminants from outside come in. So it's a very good way to protect schools, classrooms, hospital wards, etc., etc. To do the opposite to that and achieve negative pressure in a room, and this is done frequently in hospitals for isolation wards and other areas. Here, all the room is pulled through the HEPA air purifier and the room is put under negative pressure. This means that anybody or any contaminants in the room stay in the room, and you can eventually, or you can isolate any suspected people who are infected, keep them protected from the rest of the building's occupants, and keep everybody safe in the facility. Some real examples. Again, we keep saying plug and play. Here's an application of a building in a cam cleaner, bringing in some fresh air from outside through an external wall. Very simply remove the ceiling tiles. As you can see here, it's a UK or Ireland application, so it's a plug that's plug and play. And then we know we're bringing in air through the filters in the system. To make it look neater, we build it up, enclose it with some ceiling sheeting, introduce the air outlet grill, and importantly, here we can improve the performance of your aircon system, because in the top right of that picture here, you're looking at an air conditioning system, which is heating, cooling, maybe humidifying the air, but the filters are typically not to the standard needed during this current pandemic. At one stage, it was advised not to use them. But in this instance, you're delivering HEPA filtered air to your air conditioning unit to allow it to condition the air. So you're polishing your air. Again, if you don't want to build in a unit, we recommend plug and play mobile solutions from our air purifier range. But if some fresh air is needed, in this instance, it can be adjusted. That in this, what we're looking at here, you're looking at the HEPA air purifier, which has 2 HEPA filters in the system, bringing in some fresh air through an open in a closed window. Through one side, one HEPA filter. The rest of the air from the room goes through the other side, through the other HEPA filter, and the air outlets on the bottom are positioned over the heating system so that we heat that air coming into the room. So in the picture, fresh air is delivered. It's heated to take the chill, which we all want to protect ourselves from as well in December, January, February. But overall, you've got clean air. And remember, Camfil, clean air made for improving life. It's in our DNA. So with that,
thank you, Alan, for the clear explanation. Let's now have an overview of Camfil solution regarding air cleaners. At Camfil, protecting people is one of our mission. If there is a need for clean air within a facility, and this has never been a more important time, then you can be sure that Camfil will have a solution with a full range of air filter and air cleaner. Based on the volume of the room and occupation, you can easily estimate which one of the air cleaner will fit to you. An IoT device, Camfil Air Image as an option, is allowing you to measure and track your indoor air quality versus the WHO guidelines to make tangible for your staff, your customer, the fact that the air is safe. For sure, all Camfil experts are fully dedicated to support you to design a healthy workplace. As an example, the CTM, here it is. It is the ideal unit for your office or workspace environment, equipped with 2 H14 HEPA filter, the unit will capture 99.995% of airborne contaminant and also VOCs with a layer of activated carbon media. The unit is easy to move and is ideal for environment between 50 to 75 square meters, dependent on air changes requirement. The plug-and-play solution can help upgrade your environment to increase air changes, but also capture the airborne contaminants. Its large filter media ensure that the HEPA filter has a long operational lifetime. Breathing air is essential for life. It is an instinct, the very first thing we do when we are born. Naturally, we expect the air to be clean, but we do not instinctively question the quality of the air we breathe. The scientific community and global media continue to report on the link between human health and poor air quality. But national and international organizations are addressing this problem. As the health and economic impact become more apparent, they strive to set new standards and raise awareness, such as the latest WHO guideline as an example. At Camfil, we view it's our responsibility to support this global initiative, so you can take a breath with total confidence. Now we'll pass over to Alan regarding simple tips.
Thanks again, Stefan. So all air purifiers are not equal. Some may seem low cost. Let's look at an example of a Camfil versus non-Camfil air cleaner. Unit cost should definitely not be your key consideration. You got to look at the operational efficiencies. Is it reliable? What's the filter performance? What's the airflow requirements? Does it deliver the correct ones, etc.? You've got to look at who you're buying it from. We have over 55 years HEPA filter production experience, so we know what we're talking about. All of our HEPA filters are individually tested, critically important. And the efficiency. HEPA air purifiers capture 99.995% of contaminants, but lower filter classes can take 3 or 4 additional air changes to achieve the same results. So always ensure you've got a H13 or H14 HEPA in your unit and the lifetime of your filter. We size ours to last, if possible, 14,000 hours or on average 18 months. In some other air cleaners or air purifiers, you can be changing your filter every 6 months or sooner. So again, look at the real cost. Recommendations are 2 to 5 air changes to protect people, or we're protecting people here. So make sure your unit delivers that airflow, or else you may need to buy more units than you initially think. And again, your false economy of choosing a lower cost air purifier is killed. So please remember, we use up to 40% less energy. So running costs again, filter cost, energy, and maintenance will all be less with our unit. And here you can deliver some real life cost savings or lower the total cost of ownership of running your system. So please be very clear in the unit you choose. Thank you.
Thanks again, Alan. Thank you for listening. Now we'll pass over to my colleague David for the Q&A session. Dave, the floor is yours.
Brilliant. Thanks very much, Alan and Stefan. We have a lot of questions here, and we timed this to go for half an hour for more questions to be available through the day. For the first question, what I see on the screen is, do windows need to be opened when using a HEPA air purifier, or can they be closed?
The recommendation is that the recommendation states that you've got to maintain the air change rates. So yes, the windows can be closed, but just be very, if you're maintaining the air change rates, but you need fresh air. We all need fresh air. So closing windows and sealing the room and only recirculating the air in the room will deplete the quantity of oxygen. So I'd suggest using a CO2 monitor to make sure that the air in the room has sufficient oxygen, that people don't start to fall asleep or feel queasy. We all know that feeling. So it depends on the application. Get advice from us locally, but typically you can recirculate the air in the room once you've got enough oxygen coming in. Try and get a system, as I showed in one of the pictures, where you can bring in some air from outside and recirculate the room air inside as well. I know that's difficult in our current weather. We're not in summertime, but the recommendation is to make sure you maintain the correct ventilation rate, but also have enough oxygen. Hope that answers that.
Perfect.
Exactly. It was the purpose of the study from the CDC. So you can both open the window at least a few minutes per hour and use an air purifier to achieve the best result.
The next question I see here is, have you any studies for offices or schools of particle counts pre and post installation for portable HEPA filter air purifiers?
I'm very sure we have. We've done a lot of work around Europe, so maybe David can probably answer it more, but I know we've got some particle counts before and after in a number of applications. So whoever that is, they reach out directly to their local country or myself, or just come to the webinar email address. We can give you some details, but we have definitely tested many installations in many applications and given before and after results. So I'm very sure we have that for the industries you mentioned.
Absolutely, and also it is
Yes.
part of the sales process to have a site survey before and after.
Perfect. Sorry, let me keep going. Just loads of questions popping in here. Just to continue on with that, yes, we have as Stefan says, it's part of it. We always do well, not always, if needed, we do a before and after analysis for our installations to show the proof of concept. Can you explain more about where to place the air purifiers?
Well, positioning of the air purifier depends on what's in the room. All we will say is, like, it doesn't have to be in the middle of a room. Air will move depending on the heat in the room. So it'll fall in cold areas, it'll rise in hot areas. So air will naturally circulate in the room depending on the position of people and thermally generating devices. So position it somewhere that it can get as much air into the unit as possible, clean it and return it to the room. Just don't have the inlets or outlets blocked. If that has to be the middle of the room, perfect. But if it's in a corner, away from the walls, away from curtains, away from anything that's blocking the performance of the air purifier, that's all we would ask you. Anything else, Stefan?
No, I think once again, it is part of the sales process. So during the site survey, we have a recommendation for both the number of units and also the localization of the units.
Perfect. Do Camfil units come with UVC lamps? Can you define pros and cons for UVC and why Camfil don't have UVC built in our air purifiers? Would you want me to answer that one?
Yes, we don't is the answer.
Yeah, we don't utilize UVC because HEPA filters captures the contaminant. So if it's a microbial contaminant such as a virus, it will dry out within the media, and within 24 hours it becomes inactive. So adding extra devices such as UVC or other technology into it becomes an additional cost, and when the system doesn't need it, we don't feel the need to put them into the systems.
I can talk from a pharmaceutical background. They've used UV for many years, but it's really for sterilizing surfaces where the light is acting on surfaces. So, you know, with air cleaners, you don't have, or you shouldn't have, huge airflows. The airflows can be quite low, but the air speed is important. So number one, is the air being exposed to the light for long enough to have any effect? Number two, will you get dust on UV lamps? This can be a high cost. There's an issue with UV lamps. They may extract ozone, and as I said in my part of the presentation, be very sure that whatever technology you choose does not generate more potential contaminants. So they're not really for very dusty areas from our experience in the pharma industry. And realistically, you're dealing with indoor environments that, even though you may not see it, can be much dustier than you expect. We do not live inside in very clean environments 8 times out of 10. So just be very careful with using technologies that are maybe not ideal for the situation. And as David says, HEPAs work very well.
Next question here is, can CO2 monitors run at higher levels of CO2 when you use a HEPA air purifier? Again, what HEPA air purifiers are removing is particulates. So CO2 isn't a measure of clean air. So yes, CO2 levels can be slightly higher. I think there's a table put together by Harvard again on this, which shows that we can have an elevated level when you use HEPA air purifiers. It's, again, as Alan said, you still need a bit of fresh air every now and again. Clean fresh air, was it, but by opening a window every now and again, or if you have a mechanical ventilation system, and making sure that that's kept low enough is always healthier for people. but again, CO2 levels can go at slightly elevated levels when you're using HEPA air purifiers. You can utilize your CO2 monitors. Does that make sense? Is that okay, Alan?
Yeah, I think we work very closely with a lot of the monitoring companies, and they will, as we say, CO2 monitors or monitors in general monitor and let you know you have a problem. The solution is either getting fresh air or, more importantly, cleaning that air. So the monitor is there to let you know you have an issue. You've got to take other steps to resolve the issue, and that's where air purifiers and air cleaners are a vital part of your strategy.
And coming back to the healthy building strategy with the 3 main points: increasing ventilation rate, increasing filter efficiency, and 100% supply air, so fresh air, and supplementing with portable air cleaner. These are the 3 pillars in order to meet the requirements.
Perfect. In naturally well ventilated classroom environments, is it still advisable to have air filtration? Air filtration is obviously a requirement from, we talked about the World Health Organization standards. So when we're talking about breathing clean air, air filtration is very important. The air outside isn't always clean. There's other contaminants that can cause pollutants to enter from traffic, from cars outside, to nearby factories and other contamination sources. So filtration is always an additional benefit to these environments. Again, the World Health Organization released an air quality guidance just a month ago, and it gave you levels of PM 2.5, PM 10, SO2 levels, and stuff like that. And if your room is within those levels of guidances, then of course your filtration may not be as prominently needed, or HEPA air filters may not be as prominently needed. But if you're not within those limits, then HEPA air purifiers or filtration would be required.
And also, I would like to raise the CDC study that clearly shows if you open the window, the particle reduction is around 29%, and if you're supplementing this process with an air purifier, you reach 91%. That means you are 3 times more efficient. So this is something to have in mind.
Yeah. For schools and offices, how can we determine the air change that open windows provide? If we are using standalones to supplement this seems to be vague.
It is.
Yeah, it's very vague because windows in general, it's all depending on the size of the window, the size of the opening, the size of the room, to determine the actual, and then how windy it is outside and the airflow direction from outside. So determining what it's achieving from natural ventilation is always a little harder, and that's why CO2 monitors have been brought in to try to help with that element of it. But determining your exact CO2 levels, the best thing, as I said, bring in a professional. Doesn't have to be a Camfil professional. Bring in a HVAC professional. Bring in somebody who knows about these environments, and they can do a quick analysis for you. It's fairly easy to do for an industry professional. Okay, what happens to all the contaminants on the HEPA that are filtered out? Would it be safe to change the filters? I think we answered that. All the contaminants are trapped within the filter. If it's a microbial contamination, it dries out, becomes inactive, and dies within 24, 72 hours. Is it safe? Of course, yeah. Camfil, we have handles on the filters to make sure that they can be taken out, disposed of in a proper and easy way, so you wouldn't have to touch any part of the media, even in. But that wouldn't be a concern in any case anyway.
This is where,
Stefan?
Yeah, this is where I'd cry out to all HVAC professionals. Any air filter is removing contaminants of one form or another. So when you're changing any air filter, you should operate under strict safety protocols and wear gloves and wear masks. The filter is there to protect people from contaminants, be they outside diesel fume or noxious dusts, etc. So they're going to be in the quality in the filter fabric. So a simple method: wear gloves, wear a mask, remove the filter, and put it into the packaging from your new filter, and then put your new filter in. Close the door, walk away, and dispose of things correctly. In various industries, there are much more regulated ways to change filters because of the level of hazard. So again, adhere to local guidance, but my guidance, and I think Stefan would agree here, for anybody working in an FM or a maintenance facility, protect yourself, always wear a mask, always wear gloves, always wear a boiler suit or some kind of a suit, and don't go home to your wife and children covered in contaminants, because it's been a danger for many years. It's only now that people are more aware of it. So please take care.
And exactly, and not to forget the glasses. And I just would like to raise the point that there is no extra recommendation regarding the filter replacement, because if you respect the basic rules of protection, is perfectly compliant with the situation we are facing today.
Perfect. Would an air purifier reduce the need for ventilation rates of 10 litres per person per second? Would an air purifier in a room mean occupancy could increase? Again, air purifiers are used as a supplementary system. So when you're talking about, you wouldn't be, if you're not achieving 10 litres per second, per person per second, you're going to use your HEPA air purifiers to supplement that to try to achieve those rates. So when you're sizing your air purifiers, you're going to be looking at your current airflow. You're going to be looking at how many air changes you have and how you can supplement that to protect the people. And that will make a decision for how many people can come into the room. Alan, would you want to add to that?
Yeah, I agree. It's, again, the air cleaner's job is to change the air in the room and clean it. The introduction of oxygen or the reduction of CO2 levels needs to be by some kind of ventilation in the room. You need to get fresh air in periodically, or as David said, on occasion, or else link your air cleaner to the outside environment. But we cannot live without fresh air. We need fresh, but importantly, clean air. And you've got to strike a balance. But again, use a local HVAC professional.
I understand that COVID-19 is an airborne contaminant. Do HEPA filters protect people from COVID-19 completely, or are they to reduce the rate of spread? As Stefan said, we can't stop. HEPA filters aren't going to stop people from being close to each other. They're not going to stop people from hugging and kissing and doing and breathing close and doing things that maybe we shouldn't be doing, wearing masks, not wearing masks when we're speaking, for instance. So HEPA air purifiers are a part of the layers of protection, and they shouldn't be considered as, I have a HEPA air purifier here, I can do what I want. It's a layer of protection. I think that's very important to understand for everybody.
And if we look at the studies that have been done, particularly in schools and hospitals, they've noticed a serious, and they've tested for the virus in the rooms. In the Cambridge one is a good one. Yes, there's no COVID present during the test, and even with people with COVID in the rooms, the COVID virus not being found around the room. But if you're beside somebody and they cough all over you, no ventilation system in the world is going to, if they have COVID, no ventilation system in the world is going to stop you breathing it in. It's position, it's common sense, and it's obeying the protocols that are in place by taking as many steps with the technology that's available to protect all the people in the space. So yes, it will dramatically reduce the quantity of virus available to infect somebody. But if you're right beside an infected person and they cough on you, it isn't a silver bullet. It's not humanly possible to stop that.
The other question is, air purifiers, can they be suspended from the ceiling, or can they be anything other than floor mounted? What is our recommendation?
Oh, you've seen in the couple of pictures we've shown that you can build them into ceilings and hide them. We gave that example. So yes, we can put them in the ceilings. We can put them on the wall. If you don't have floor space, there are many solutions available.
Especially with the Camfil version that open plenty of capability to customize your installation.
And even aesthetically, the example we gave, we built an enclosure around that housing. If there was space above the ceiling, it could have went above the false ceiling tiles and a small inlet grill in one of the ceiling tiles. There are many, many options. And again, a local professional from Camfil or other HVAC professionals more than willing to help, particularly in this current environment, even though we're busy. We really need to get as many people back to normal as possible.
Why not use an ULPA filter rather than a HEPA filter? Sorry, I'm just going through these questions. Yeah, why not use an ULPA filter rather than a HEPA filter, Alan? Do you want to answer that question?
Particle size we're dealing with, a HEPA filter is 99.995% efficient. An ULPA filter may be slightly more efficient, but you'll have increases in pressure drops. It'll catch a hell of a lot more contaminants. The pressure, the lifetime can be reduced. So H13, H14 is more than sufficient. When Camfil look at a problem, we design a solution that, number one, will solve the problem, but number two, that the filter life will be long, low pressure drop, low energy consumption, and you don't have to change filters every 6 months. Like you gotta look at it from a balance. We want to catch as much particulate and contaminant as possible with the lowest total cost of ownership, and that's our message. That's what we want to do. So ULPA's overkill. H13, H14 at these particle sizes more than sufficient and proven to be so.
And this is the right balance, and this is what we can find in all the regulation or the documents regarding the best practices regarding air management.
What is the filter lifetime? How do you know when it should be changed?
Maybe David, you can take that regarding the air image, etc., and some other.
Yeah, or Stefan, do you want to take that?
Yes, for sure. If you want, so you have a sensor inside the cam cleaner with a light, and when the light is red, it's time for changing the filter. So it is very user friendly and very simple.
And as we said, in tests and practices, we have up to 14,000 hours. So whether you use that 24 hours a day or 6 hours a day in a classroom, it'll depend on the level of pollutants that the filter is actively catching. The pressure drop will increase as it collects pollutants. As the pressure drop increases, the fan will start to slow down. The sensor will tell you when it's time to change the filter to ensure you have the correct airflow. But typically, we're designing for 18 months where possible. We want filters to last 18 months to 2 years if possible. If you're in a very, very dusty environment, that's obviously going to be different. But most indoor environments, you're not dealing with metal shops or workshops. You know, in the classroom where you're dealing with your woodworking teachers, it might be slightly different. So again, we try to size it for 18 months at a minimum. But every single indoor air quality indoor space that requires indoor air quality has a different level of pollutant, so it is not one case fits all, unfortunately. But you can be sure to be the longest life available.
Perfect. What particle size does the Camfil HEPA filters capture?
So this is for you, Alan. As a pharma specialist with the MPPS, you will explain everything.
HEPA filters capture a range of particle sizes, and as I said in the beginning, when I spoke about the test standards, the EN 1822 test makes us, first of all, test the filter media. And here we test for what is the most difficult particle size to catch. So most people think a HEPA filter is tested against 0.3 micron particle sizes. In the factory, it's actually tested against the most penetrating particle size. And this can be down to 0.12 of a micron. Bear in mind, a micron is 1,000th of a millimeter. So we're looking at testing against 0.12 micron and lower and higher, and we get an efficiency of 99.95 or 99.995% at that particle size, depending on H13 being 99.9939, H14 being 99.9949. So 3 and 4, 13, 14. So it is efficient against particles down to 0.12 microns and above, and as the most penetrating particle size. And we are the only stroke of luck we have in this whole godforsaken pandemic is that the virus we're dealing with tends to be around that size, and we are very, very lucky that it tends to be then traveling on a droplet or a larger particle, so it's very, very easy for a HEPA to catch.
Exactly, and also please remember that a virus does not travel alone. He needs a particulate to travel. And this is the reason why the particulate removal is a key success factor to fight against the COVID-19.
A common question what's coming up here is like in a typical sized primary school or office environment. So I think someone has here as a 170 meter square meter cubed environment. What's our recommendation for how many units would you need? Do you mind if I take this one?
Yeah, go ahead.
Yes, go ahead.
As we had said before, the idea about sizing of units is all based on a number of factors. So one is going to be obviously your sound level. You want to make sure that when you're utilizing, or for the first one we go is airflow rate. So we're going to decide of how much airflow is needed within the environment to create the air changes that are required. But what we need to identify is the sound level. So what is the manageable sound level within the classroom environment? Maybe you're only the classroom can 52 decibels is okay in the classroom. Maybe only 46 decibels is okay. So we need to identify what is from the school environment the manageable, because that can change the number of units. Because if you say I can't work with at 56 decibels, then you may need to use units with a lower fan speed so they can achieve that. So generally, if you're looking and obviously so it's every environment is slightly different. I would say in most classrooms we're probably looking at 1 unit at that for that size, because you're going to be creating 2 to 3 air changes, which is required. But in some instances where noise levels or other factors come into place, you may need a CEM and a CES or one of the bigger units. So okay, that one's done. Do any of our products have pre-filters for particularly dusty areas?
Yes.
Yes, in the Camfil, for example, for the Camfil in example, not in the CTM, because as Alan mentioned, this is a plug-and-play solution for a classroom and office, and in that case, it is not a mandatory. But for the Camfil version or the industrial version, we use a pre-filter.
Yeah, our CC 800 ranges, our CC 2000s, are anything what we'd call our industrial range will have a pre-filter in there. Our CEM has a pre-filter, but it's a molecular layer for VOCs and other nuisance odors. Can you please, when you say 1 per classroom, roughly what size? Yeah, as I said, I'm saying 1 per classroom at about 170 meters cubed room is probably where I'm kind of positioning 1. It could be, as I said, depending on the noise level requirements and stuff like that. Is there any other question? So they're looking for. So someone here is looking to know about split air conditioning units. How can Camfil filters help with split air conditioning units?
Split systems or split air conditioning units, typically, as I said in the presentation, any split systems that you mounted in the ceiling or on a wall, they typically have a small dust filter in them to protect the components of the split system itself. It is to protect the coils and the moving parts of the split system, and they're serviced once a year, once every 6 months, depending on your local contract agreement with your local provider, and they're typically taken out and hoovered in most instances. So the filtration technology involved in most aircon applications is not filtration to protect people, it's filtration to protect the split system or the product itself. So yes, we can help by positioning an air cleaner in the room. The room is then obviously, it's got much, as you said, 99.995% cleaner air. So your split system is then handling a much cleaner level of air. So its filter is by default not going to have to handle all the dust in the room, and it's protecting the split system better. And it allows the split system to do its job, which is to condition, air conditioning. So to heat, cool, or humidify the room, whatever it's designed to do, but filtration is typically not one of its skills. That's my answer. Maybe Stefan, you can go a bit further.
No, exactly. I have nothing to add. I think This is not a filtration device, and this is not an air purifier. This is just to refresh or to warm the temperature in the room. That's it.
Okay, we've been going on for half an hour with questions, which is brilliant, and there's more questions coming in, but I'm just going to take one last one, just because there's so much time. There's so much, there's loads of people asking about the pricing and stuff. We'll, if you've asked a question about pricing, one of our sales engineers will just reach out to you and give you a quick quote for a price. But obviously, someone wants to know is how do we engage a local Camfil engineer to help with a needs assessment and purchase? For me, the best.
David.
Yeah, this is why I chose this last question. It just came up there. We have Camfil offices, manufacturing plants all around the world: UK, Ireland, France, Germany, USA. We have production all over the place, so as well as sales offices in many different countries. So if you visit our local websites, just put into Google Camfil and the name of your country, we should come up number one according to Google algorithms. And if you go into contact, click, or this presentation will be sent out to everybody who wants it, click the link and you can find your local person. And that's it from everybody. I hope that this was a worthwhile presentation. Thanks to everybody. Great numbers for joining and staying for so long. And again, if you have any questions, please email camfil.webinars@camfil.com. The recording will be sent out to everybody in the next, I think, 1 hour, and then 24 hours for whoever wasn't here. Thanks very much, everybody.
Thanks very much.
Thanks, guys. Stay safe. Cheers.
Stay safe. Bye. Bye-bye.